Chapter 10. So chapters 10 and 11 were confidence intervals. So let's just do a quick summary. Chapter 10 is CI with proportions, which would be P hat, P1 hat minus P2 hat. Chapter 11 was confidence intervals with means. What are the three kinds of means we talked about? D bar. X1 minus.
So why wouldn't mu be?
Oh, mu would be, like, mu is the exact value for X bar, right?
Yeah.
Is that means one mean, whereas opposed to it's one mean, paired means, or two means. Chapter 12 was hypothesis tests with proportions, right? And what was chapter 13 about? Well, with means, which could be any of the same cases. Does that make sense?
Yeah.
So single mean, paired means. And in the case of 10 and 12, you use what kind of statistics? Z's or T's?
Z-stat.
Z-stat. And then in 11 and 13, you use T stuff. Okay, does that make sense as a reasonable summary? And these things do all have a pretty similar structure. I would just go through your notes and try to make notes on your note sheet of like specifics of their formulas. Like in some cases you use the null value versus not. Okay. Suppose that a survey is done to estimate the proportion of all U.S. adults who think that texting while walking across an intersection in the crosswalk should be illegal. In the survey, 54% of the randomly selected sample said that this should be illegal. So who do we care about? All U.S. adults, because we don't care what teenagers think.
Yeah.
We're adults.
You guys are all adults, right? Close?
I'm still a teenager.
You're still a teenager?
It's okay, I'm not offended.
Okay. You get to pretend you're an adult in the college class. It's all
Yeah,
good.
exactly.
No offense to teenagers. We do actually care what they think. Just,
You
We're
shouldn't.
Yeah, over 18 is an adult. What's the population parameter of interest? So first of all, is it a proportion or is it a mean? It's a proportion. What's the giveaway?
54%.
It's a percent, right?
Yeah.
Percent proportion. You gotta love the alliteration in math class. So it's the proportion of U.S. adults who think texting and crossing the road should be illegal. So the things you have to have there to really get this right is, first of all, be clear that you know it's a proportion. Does that make sense? And then a proportion of whom, and then like what's their defining characteristic. Does that make sense? What makes them special? Who is the sample?
25.
The 10,025 people asked?
1,020.
Oh yeah, 1,025. Yep, you're right. What is the value of the sample statistic?
25.
P hat equals 0.54.
Can we shorten stuff? Like instead of saying proportion, can I just put prop?
Yeah, that's fine. As long as you make it obvious you mean proportion and not mean. Does that make sense? Yeah.
I have 54%, not 45%.
Oh, that's fine too. Yeah. It's the equivalent, right? Same thing. Yep. Okay. Explain whether the width of a confidence interval will increase, decrease, or remain the same as a result of the following changes. So remember that confidence intervals have the general format of this sample statistic plus or minus some multiplier, right?
Yep.
Times the standard error of your sample stat. Okay. So which part of this formula is affected by the confidence level? The multiplier. So the multiplier will do what when your confidence level goes from this to that?
Gets wider.
It will increase as the confidence level increases. This makes a wider or smaller interval? Wider interval. Okay. A planned sample size is decreased from 500 to 100. This will, okay, it will affect the sample statistic, but that doesn't affect the width. True, does that make sense? Just affects what point you're kind of centered around. So what's gonna, the standard error, right?
Yeah.
So the standard error, will it be bigger or smaller with a sample of 500? Will be, remember that's root, what is it, like root P1 minus P over N, right?
Yeah.
So bigger denominators make this number.
Makes it narrower.
Yes, bigger sample makes it narrower, right? Smaller sample makes it wider, and that's because smaller samples make larger standard errors. Okay, so if that's true, the interval will be what? Wider or narrower?
Wider.
Okay. In a randomly selected sample of 400 registered voters in a community of 220 say that 220 of them say that they plan to vote for candidate Y. So find the sample proportion planning to vote for candidate Y.
It's the wrong candidate.
It's the wrong candidate?
Yeah.
I just don't believe in what they stand for.
I'm gonna have some kids in mess, never mind. Okay, so 220 over 400, 0.55. What proportion of this class supports shortening the amount of time that you can campaign for an election?
Oh my word, yes.
Some countries do limit it, actually, that they say you can campaign for 3 months.
Yes.
Anyway.
Let's just do the day before.
Give me your pitch now.
All right.
Vote for me. Polls are closed.
Standard. You get lots of votes. Standard error. Okay, so the formula for this was root p hat 1 minus p hat over n. So what goes in for p hat? And 1 minus 0.55, which is 0.45, yep, over, yep, and that comes out to be, I got 0.025. You're pretty safe to round to 3 decimal places, it's totally fine. Okay, does that all make sense? Okay, now I think the next thing we need is our multiplier, right? So first find a 95% confidence interval. Now there were tables that we got this from. It wasn't actually a Z table, but yeah, we used Z star equal to 2. If you look back at your notes from chapter 10, you'll have a little table that gives you multipliers for common confidence levels. I think we gave you like 95, 90, 98, 99. Okay. So Z star is 2. So 95% confidence interval is 0.55 plus or minus 2 times 0.025. Or 0.55 plus or minus,
0.05.
or 0.5 to, which you could have also given in percents as 50%. Yep, either one of those is fine, okay? I don't care if you say 0.5 to 0.6. I don't care if you say this 50% to 60%, they're both the same thing. So let's insert with 95% confidence the proportion who will vote for candidate Y is between 50% and 60%. Okay. What should happen to your interval if you make the confidence level 95%? Sorry, 98%. It's going to get wider, okay? I know you probably don't remember what the multiplier for this case is 2.33. Did you remember?
I did.
Nice, good job. So you have 0.55. Sure, I want to take them home. Plus or minus 2.33 times 0.025. So what did you guys get for 2.33 times 0.025? I got 0.058. Is that? Yeah, okay. So that's 0.492 to 0.608, or just below half to 60.8%. So if you're looking at this interval making a conclusion, would you think that candidate Y is likely to win? Yeah, once they get over half, it's likely that they're going to win, right? And it's pretty likely that the true proportion lies in this interval. This procedure ensures that 98% of the intervals you found, but this low value does maintain that there is still a possibility, right?
No, I wrote it down as 42.9.
Oh, as opposed to 49.2, yes. So, and the only thing that changes here is that with, you say, 98% confidence, and the rest of it, copies from the last part. Okay. So this is a question that you guys had a little bit of a hard time with on your test, or your quiz on this topic. If anybody got something wrong, it was this question. So this question is answering where do these multipliers come from. So do you have a Z table on you? Yeah? So get out your Z table. We want to find the multiplier that gives us 97% confidence. And here's the picture associated with that. We have this bell-shaped curve. We want Z star values so that the middle area is 0.97. I wrote 9.5 and that's not supposed to be 7. Okay, so you need to figure out what are the numbers so that the area between them is 0.97, and that means how much is left in each of the tails. 0.015. Does that make sense? Okay, so look in your Z table for a P equal to 0.015. And the thing that's different now is that you're looking inside that stuff and you're figuring out what z did that come from. So look at the negative half and look for 0.015. Or as close as you can get.
Negative 2.27.
Hold on a second, I gotta find it.
Or negative 0.2.
So, oh wait, whoa, hold on, 1, 3, 1, 2, 5, 1.
Negative 2.17.
So I see one that is actually 0.0150. Did you guys see that? Negative 2.17?
Yeah.
Yeah. So this value right there is negative 2.17. The multiplier is the absolute value of that number. So z star in this case would equal, go ahead, yeah?
2.17.
2.17. Does that make sense? Okay, and on your test, I'm probably gonna ask you to draw the picture to kind of illustrate that you know where it's coming from. I'm giving partial credit if you don't get it right. Okay. So a study was done to determine whether there is a relationship between snoring and the risk of heart disease. Who thinks there will be an association? Yeah, usually there is. But that's because snoring tends to occur with,
Sleep apnea.
and which occurs with
Uh,
obesity,
oh,
overweight, right? Yeah,
what's
which,
the other one?
polyps?
No.
Okay, moving on. Okay, so of the 1,105 snorers, 85 had heart disease, while 24 of the 1,379 non-snorers had heart disease. So what's the proportion in the first group that has heart disease?
85 out of
Uh-huh.
5.
Yep. Okay, 85 out of 1105 comes out to be 0.077, so 7.7%. And for the so that's the snorers. And the non-snorers?
24 out of 1379.
I got 0.017. Is that okay? All right. Find a 95% confidence interval that estimates the difference of proportions of non-snorers and snorers who have heart disease. So I will specify what order to go in. Let's use snore minus no snore. So first thing you find is P1 hat minus P2 hat. So 0.077 minus what?
0.017.
Okay, that comes out to be 0.6, 0.06. Okay. Step 2, let's get the standard error of P1 hat minus P2 hat. So this is P1 hat 1 minus P1 hat over N1. P2 hat 1 minus P2 hat over N2. Does that ring a bell? Okay. So 0.0077, 1 minus that number. My N1 is 1,105.
Yes.
0.017, 1 minus 0.017 over 1379. Okay. Gesundheit. So I got that this was 0.009. Officially I got 00 and then 88, but that rounds to 0.009. Okay. Did you get the same thing? Is 0.06. So 0.06 plus or minus 0.018, right? So that's 0.042. Is that right? What about in the upper end? Okay. Or as percents?
2 to 7.8.
Okay. So last question about this. On the basis of this confidence interval, can you infer that the population proportions with heart disease differ for snorers and non-snorers?
Yes.
Yes. Why?
This does not contain zero.
The interval does not contain 0. So no difference is not a plausible value. So with 95% confidence, snorers are between 4.2% and 6.8% more likely to have. Does that make sense? Is that what we were talking about?
I thought it was 7.
Or was it? Oh, it might have been 7.8. I might have been wrong. What was it, 7.8?
7.8.
Yeah, so sorry. I'll fix it. Yeah, there's no reason that would have changed. That's just reiterating. Okay. A new survey is done to estimate the proportion of a population that favors a new tax law proposal for a city. In a random sample of 400 city residents, 43% favor the proposal. Make a 95% confidence interval for the true population of all. Oh, this is silly. I must have copied and pasted. Of all people, taxpayer opinion. Okay. So what's the sample proportion? We even told it.
Who favor the new tax law?
And that'd be at
Person like who's
0.43, right? Then find the standard error of that p-hat. 0.43, 1 minus 0.43 over 400. That comes out to be 0.02248 is what I got, so 25. And what's your multiplier you use for this? 2. 0.43 plus or minus 2 times 0.025. So 0.43 plus or minus 0.05. So what's that on the low end?
0.3.
48. That's okay. It's okay. 38% to. Okay, or that one. And I probably should have said 2 instead of and, but semantics. So if you were this politician, should you vote for this tax thing?
No, you
No. Anyway, so on the basis of that interval, can you infer that half population, can you infer that fewer than half
Yes.
favors? Yes. The interval falls entirely below 50%.